with that overview, I'll hand it back to Sarush to kick off our fireside chat. But first, a message from Joanna at our partner, Daimler Truck North America. Thank you.
Hello, everyone. I wish I could be there in person with you all, but I'm excited to be with you virtually to share some words about Aeva. At Daimler Truck, we keep the world moving towards a safer and more efficient future, and that future depends on having the right technology and the right partners. For the past 18 months, we've been working closely with Aeva on their production program. Together, we're integrating their 4D LiDAR technology into our autonomous-ready truck platform. And I'm really pleased to say progress is going strong. We're hitting our joint milestones and have already incorporated their LiDAR technology into our next iteration of trucks based on the 5th generation Freightliner Cascadia. With Aeva's start of production planned for 2026, they're a major contributor and enabler of the market launch for our autonomous trucks in 2027. Their ultra-long-range LiDAR technology enables level 4 autonomous driving at highway speeds to detect objects at a far distance and leave sufficient reaction time for the virtual driver. We have full confidence in Aeva. Their state-of-the-art technology, their team, and their ability to deliver at scale have been key to this partnership. We are proud to continue to grow this partnership with Aeva and bring their next generation of autonomous driving technology to life in our autonomous-ready Freightliner Cascadia. And we will do that safely, efficiently, and at scale.
Are we having fun yet? All right, well, thank you. I want to thank our panelists and our partners here joining us for the first segment of the automotive session. I'd like to introduce first Peter von Schmidt, the CEO of Torc Robotics, as well as Mike Tober, the CTO of commercial vehicles at Bendix. So maybe I'll first start with a first introduction, if you'd like to give a little bit about, your background and what is Torc about, and then we can get into the discussions from there. And then same for you, Mike, on your side. So please go ahead.
Thanks, Sarush, for having me here and this wonderful opportunity to speak to all of you. Peter Schmidt, I consider myself a veteran of the trucking industry, so I was 17 years with Daimler Trucks and did some epic things. One thing was developing the engine that propels trucks, Freightliner engines, and that was transformative to the market and the foundation of their dominating market share. Was a strategy, and then thought, what is even more transformational than a wonderful engine? That's autonomy. And then we tried a few things back then, found Torc Robotics as an interesting player in the space, because Torc Robotics was out there also for 17 years, automating big trucks that are driving in mines or for military. And there was an opportunity to acquire a majority stake in the company, supported Torc in growth for about 3 years, and then the founder decided to step down, said, hey, Peter, it's getting too big for me. Do you want to take over? I said, yep, I'm not a founder, but I've run really big programs. And now I'm 3 years CEO of Torc Robotics. Again, our core field is self-driving, Class 8 trucks, US, and we are starting with the Cascadia truck. And it's looking promising.
Awesome, thank you. Mike?
Yeah, so Mike Tober, I'm with the Bendix Commercial Vehicle Systems, and first a little bit about Bendix and what we do. Bendix is part of a global group, Knorr-Bremse Commercial Vehicle Systems Division. And globally and then locally through the Bendix organization, we provide primarily air brake systems for commercial vehicles, starting with air charging systems, air treatment systems, all the way to the wheel end hardware, so drum and disc brakes. But over top of that, we have control systems, embedded control systems, starting with our braking technology, so systems like anti-lock braking systems, electronic stability control. And then in the last 10, 15 years or so, we also introduced ADAS, driver assistance systems, up to L2 on top of that brake control system. And our focus really in this market, in the commercial vehicle market, is on the active safety technology and continuing to develop that technology. I didn't think I would get to say I was the most senior member in the industry, because I have been in this commercial industry since I started in about 25 years ago. So I've worked in various technical roles at Bendix and some business leadership roles, and now have responsibility for our CTO organization here in North America.
Awesome. So we have with us two very exciting, both large-scale, leaders in your respective areas. At the same time, these are two very different fields, almost in terms of technology and also the market segments. We have full automation, autonomous trucking. We also have active safety. So maybe Peter, can start with you. Maybe we can start off by talking a little bit about what's the latest with our production program together. We've been working on for some time now, a year and a half, and I'm sure the audience would like to hear a little bit about the latest developments, whatever you'd like to share today.
Yeah. We are working together since many years. I think Aeva more or less from the start.
That's right.
So it's super exciting. And in such a development, you have different phases. You have more or less the R&D phase and then advanced engineering phase, where you really try to find out what does it take, in our case, to remove the safety driver and go fully driverless. And there are some really big challenges, especially when it comes to trucking. For example, that's long-range perception. Because a truck has 30% more braking distance, usually also because the brakes are not that strong and it's more heavy, the maneuverability isn't that good like with cars, and you start trying to find out, is it time of flight or is it frequency modulated, and that's how we started our collaboration. And then about a year ago, we made a decision and a big pivot, and I think that's also different than what some of our competitors do. We decided to go to fully production intent. So from the rubber to the roof, that we go on the target hardware, be it a redundant chassis, be it all sensors, be it the compute, not on x86 server rack anymore, but really automotive grade embedded compute. And did this hard transition about over the last 12 months. And it was now super exciting going through this integration hell, having it behind us and not in front of us. And from now on, every iteration is a fast cycle and is paying into our launch that we are targeting for the year 2027. And it was so exciting, let's say about 4 weeks ago, seeing our truck then doing the full hub-to-hub, fully autonomous. It was still safety driver in there, but it was pulling out of the hub in fully autonomous mode, doing intersections, traffic lights, surface streets, highways, mergers, lane changes, all the complicated stuff, day, night, heavy rain. That was a really pivotal moment out of our Dallas hub that we opened up 3 months ago. Why Dallas? Because our launch lane will be Dallas to Laredo. That's where we will haul freight for our customers. And so opening up the Dallas hub to prove out operations, how to operate autonomous trucks, and then on the same time having this breakthrough that we are now on our final physical hardware, that by the way is on target course, that there were the really big achievements and enabled by Aeva. Thank you for this.
Of course.
More to come. Launch
Absolutely.
27 is still stable, and then scaling quick in 28.
Awesome. And maybe to touch on that, you talk about scaling and launching. Can you talk a little bit about the scalability of Torc and Daimler Truck's platform as you think about, both from manufacturing scalability as well as kind of adaptability across platforms? Obviously, it's no secret Daimler Truck is, one of the leaders in the space with significant, almost 40% market share in North America. Freightliner, 100,000 to 200,000 trucks a year, and for us, why that matters is, obviously significant content per vehicle. Every tens of thousands of trucks means hundreds of thousands of sensors for us. So we have to go ahead, start on the production side later next year to be able to support your demand in the following year. How can you maybe explain or describe a little bit about the flexibility of your approach and how you see the scalability and the importance of that as we go towards SOP.
Yeah. I mean, first of all, the key ingredients to scale is that you have a great product. And you assume for a moment autonomy in principle is solved. And you see a lot of driverless taxis in San Francisco and many, many other cities. Then it's all about, do you have the unit economics right? So what's the cost of the truck? And what is the cost to operate an autonomous truck? And in the end, customer traction. Both of it looks phenomenal currently. I think we have by far the best unit economics out there, by the way, also enabled. It's great to have a great technology, but also your sensor needs to hit certain price points, and it does, which is great. That enables us to offer a really attractive product to customers who then really buy in. The second thing is you need to develop a product which is pretty flexible, especially with autonomy. And you know, there's this vintage style hub-to-hub driving where you have an airport, if you drive manually to something, then you have a middle mile in autonomy and manual driven at the end. This is not really a product that can scale and that customers really like, because you are breaking end-to-end process into 3 pieces. So it's a nice tech demonstrator, and it might be a good entry, but nothing that can really scale. So we developed our technology right from the beginning that we more or less can drive point to point in 80–90% of all cases. We can drive from an existing customer location, distribution center, to an existing customer warehouse, and doing the full journey. And only in absolute rare cases where the warehouse, I don't know, is middle of New York, we would do this driving obviously in manual, but 90% of the cases. And that's important, that you design your product also not too a lane or too narrow, but really broadly, and that we did. And then talk to the customers, and in the end, I think there is no limitations. It's really about now thoroughly preparing a launch. It will be all about, and that's why it's important that it comes also from, that it's fully integrated and not retrofitted. That's a production intent or prototype, and that it comes from factories, because nothing can beat a factory in terms of quality, reliability, and last not least, scalability on cost.
Of course.
And I think all of this homework we have done, and your sensor fits perfectly in to this concept, and your team is super collaborative.
Awesome.
Supporting this. Thank you.
Yep, thank you. Same here. So maybe now we can talk a little bit about, you know, on the other end of the spectrum. So perhaps Mike, we can talk a little bit about, you know, obviously today we announced a collaboration. We're working towards bringing next generation of active safety and especially collision mitigation to commercial vehicles. I think many folks maybe in the audience would not think that LiDAR is even needed for level 2. So what's that about? Can you talk about the importance of that? And maybe we can even first start a little bit about your existing solutions, the scale of which today, and all of that.
Yeah, so our current collision mitigation systems today use our fusion product, as we call it, is the fusion of radar and camera technology. And you know, we've had a lot of success in that product. The adoption rate has been quite high. You know, on a Class 8 commercial vehicle, we're seeing on line haul type applications, we're seeing up to 70% adoption rate. And the fleets in the North American region are really seeing their safety numbers improved, mitigation of you know, on stationary objects and such to prevent collision or mitigate the collisions. But we do see that there are certain scenarios out there, which we call our challenging scenarios, that radar and camera combination still can't address. And that has to do with, examples would be low light conditions like at dusk and dawn, or even in the nighttime, and then vehicles that are partially in lane or offset in the lane, or at specific angles where, you know, you're relying on a camera learning technology that has to be able to identify all of these various situations, and in some cases it won't detect that, at least in time, to provide a significant mitigation of that scenario. And with the 4D LiDAR technology giving us, you know, at a good range, the right identification of that object so that we can confidently apply brakes on that object, that's a huge advantage that we see to potentially bring this product into our market space. Yeah, I would say, I mean, you have to keep in mind, but we're always trading off the decision to brake this vehicle. It's an 80,000-pound vehicle, and if once you decide you need to brake that vehicle, you're going with this very high deceleration, almost as much braking as that vehicle is designed to provide. And so we have to balance that, making that decision early enough that we can mitigate the collision, but also not so early or with a lack of confidence that we'll apply brakes in a situation where we didn't need to, and that can cause other follow-on effects. So again, the 4D LiDAR technology is really what we see as potentially filling that gap on some of those challenging scenarios.
Makes a lot of sense. I think maybe we can touch on a little bit about the size of the market here for ADAS and the commercial vehicle space and collision mitigation. Maybe you can help quantify that. We were talking earlier. Understand, you guys, Bendix has close to 1 million units for ADAS functionality, collision mitigation already on the roads. So how do you see the penetration? How do you see the size of the opportunity? And maybe you can talk a little bit about, to the extent that you can, kind of where you see the key kind of focus of the market and the audience.
Yeah, so when you look at the air brake commercial vehicle market, which is where we operate, typical builds for that whole market are around 400,000 vehicles a year, some higher, some lower. We're currently in a little bit of a downturn in this market, so it's lower than that. And within that market, you have your line haul tractor, trailer, semi-trailers that you see out on the highway, but you also have a significant portion of those vehicles that operate in more of the vocational segments, for example, concrete mixers and refuse and such like that. So our primary market for collision mitigation systems is on that line haul segment, which is generally in the order of Class 8's about 300,000 vehicles or so, and then of that 300,000, maybe 200 to 230 or so would be your line haul application. And then of that, like I said earlier, about 70% we see adoption rate of these technologies.
Yep. So Bendix has a majority market share in ADAS collision mitigation systems. Daimler Truck and Torc have significant market share in obviously Class 8 trucks and for the autonomous space in North America. So obviously from our side, we're really excited to be working on one common product, as we talked earlier about with our unified perception platform that allows us to reduce the cost in a way that is making it economically scalable, that we think is uniquely possible with 4D technology, so that it can apply to these very different end markets in a way that is both very long range with high velocity information, high resolution velocity information for fully autonomous, but also for more ADAS applications. So one of the things that I think want to talk about, and this I think trend will come up, is how do you see kind of future integration of these solutions? Especially we can maybe first touch on the ADAS side. When you look at the multimodality approach, right? So you talk about your existing solutions today utilize camera and radar. So from our perspective, the advantage of 4D LiDAR is provides you that high resolution distance information, but also has that Doppler velocity information. So do you see a world and opportunity, not to put you maybe a little bit on the spot here, but for combining some of these modalities and maybe even replacing some? And where do you see that potential for our collaboration in putting the perception inside at the edge, and how the integration may look like?
Yeah, I see that there's opportunity there. We want to take a stepwise approach to this. First, see how the LiDAR can really augment our existing fusion systems with the camera and radar technology. But as with any technologies like this, there's always a constant market pressure to really look at the cost-optimized installed solution for that. And I think we definitely see an opportunity here to rethink for that L2 application. Do we really need all three modalities, or can we get down to two?
Yep.
And offer, like I said, a better total cost of ownership to our fleets.
Sounds good. Maybe I think, Peter, we can chat a little bit about as we go towards production. There's obviously significant effort that has already behind us around qualification. We talked about a fully production intent stack that differentiates your approach from others. Can you touch a little bit more on that in terms of there are others in the space that are looking at different approaches around using hardwares that may be in-house developed or hardware that is developed with other multiple stacks of different partners. Where do you see that in terms of any advantages that may have for you in this kind of more partnership approach rather than in-house development approach. Do you have any view on that that you can share with the audience around development as it comes around how you separate what's in-house and what's outsourced or partnered?
I mean, that might be the blessing of also being not too early in the game. Because if you were too early in the game, you had to develop a lot of things yourself. Let's say some of the early adopters were building LiDARs themselves in-house, or buying companies are maybe not too happy then afterwards because it's hard to scale. And it's also a lot of effort and investment that goes into it. And you know, today there are great partners like you, where I just don't need to do the investment. I just invest in the partnership and the interfaces, and then of course in the part and supply development course. But that's it. I think it might be also a blessing. Gen AI technologies, simulation technologies, all the tools that you really need to do autonomous driving. There is so much more today, both on the sensor, compute, and data and infrastructure area than it was about 3 years ago or even 5 years ago. So I think now is the perfect timing where you can, with much smaller teams, much less funding, achieve a lot. And then again, it's important what you're building. Do you want to build a tech demonstrator where you push the demo retrofit prototype to the ultimate end? Or do you want to design a product at scale into target cost? And then I think this partnership approach is super important. That's the only way how you meet your cost points. And in the end, you know, in trucking there's almost no emotion. And trucking companies are pretty predictable creatures, which I like a ton. If you have a product that is safe and reliable and meets certain cost points, they will, and offers a 1-year payback, they will take it. If not, and you say it's a cool brand and it will help to support, they won't take it. They take one and put it in front of the headquarters, and that's it. So that's what I like about this, and that's why it's so important to have the right partnerships in place that you can meet these reliability levels and cost levels.
Makes sense. I know we're kind of coming short in time. I really appreciate you guys being here. Maybe we can end with you know, one question on each side. So Peter, on your side, to the extent that you can share, how do you think about the rollout plans from your functionality? How should, you know, the audience think about as Torc and Daimler Truck are coming to market, where we may first see these autonomous trucks on the road?
Yeah, that's pretty easy to answer. You will see them first on I-35 between Laredo and Dallas in the year 27. As a product, they are driving already here, that route and collecting miles every day. And we will scale from there. Our focus for now is US Class A trucking and Freightliner. And I always tell my teams, no hobbies. Let's solve this first and monetize it first once. And then afterwards, we can talk about no limits. No limits might be different vehicle classes, different regions, different OEMs, totally different applications. In principle, I like this level 2+ idea. So there are, or other things. So in the end, everything physical will need an AI that we are building. But these are all the dreams. Now let's unlock our technology on I-35, Dallas, Laredo.
Of course.
Pretty soon.
Yep, and it's also great, exactly. It's also great to actually see these trucks already with our sensors equipped running, which is really helpful just to qualify them as we go towards SOP. So, and then Mike, from your perspective, how do you think about, you know, as we talk about adoption of this kind of next generation, you know, active safety technology, to the extent that you can share, where do you think that would be first visible, and about what timelines?
Yeah, I think, I mean, first of all, you know, 5 years ago, we would have thought L4 technology was, you know, fully ramped up by now, and you know, and this need to fill this time between L4 adoption, where you know, you have the perceptions that you can mitigate virtually all accidents, maybe not all, but a large portion of it. Now we see that technology ramps up a bit slower, but that need for active safety systems and improvement in the active safety systems, the demand's there, and then we get to leverage the technology that's being applied to L4 a little bit earlier on the L2 systems, and really, again, bring that higher level of safety to the market much sooner. You know, and we would see, you know, a system like an integration like this with a 4D LiDAR as early as 28 or so, 2028.
Makes sense. Awesome. Well, I hope that gave you a bit of idea about the latest in trucking, both on autonomy as well as ADAS. We're really excited to have you here. Thank you again for joining us in New York City and taking time out of your busy schedules. But it's not about the chat here, it's about the work that we do every day. So we're looking forward to working together to bring full autonomy on the roads already in the next year or so, and then hopefully following that with commercial vehicles maybe even sooner. So I appreciate all your support, so thank you for joining us.
Okay. Thank you.